Hello and welcome to Singularity today. I'm your host, Adam Infinity. Today, we're going to explore the latest advancements in artificial intelligence research. In this video, we'll be discussing 9 recent publications that are pushing the boundaries of what's possible with AI. From improving language models to better understand user queries to developing more accurate and trustworthy conversational systems, these breakthroughs have the potential to transform industries such as customer service, virtual reality, and autonomous driving. So let's dive in and explore the exciting world of AI research. In the research titled Wings, scientists tackle a significant problem in multimodal large language models, which are AI systems that can process and understand both text and images. The issue is that these models often forget how to handle text, only instructions when they're trained on mixed inputs containing both images and text. This is like trying to teach someone who's great at reading books to suddenly start understanding complex images, but in the process, they forget how to read books altogether. The researchers propose a novel solution called Wings, which uses 2 complementary learners, one for visual elements and one for textual elements, that work together to ensure the model excels in both text-only dialogues and multimodal comprehension. The conclusion is that Wings outperforms other equally scaled models in various tasks. This research has the potential to significantly improve AI systems used in applications like virtual assistants, customer service chatbots, or even image-based search engines, allowing them to better understand and respond to user queries regardless of whether they contain text, images, or both. In the research titled Analyzing L Behavior in Dialogue Summarization, Unveiling Circumstantial Hallucination Trends, scientists investigate how large language models perform when summarizing conversations. They focus on 2 popular models, G4 and Alpaca 13B, to see if they generate accurate summaries or make up information that's not directly supported by the conversation. The researchers found that these models often create plausible but unsubstantiated inferences based on circumstantial evidence in the conversation, which is a more subtle type of error than previously identified. They propose a new way to categorize these errors and develop methods to detect them more effectively. The conclusion is that current language models are prone to making nuanced mistakes when summarizing conversations, and we need better ways to identify and correct these errors. This research can have a significant impact on developing more accurate and trustworthy conversational AI systems, which is crucial for applications like customer service chatbots or voice assistants. Potential use cases include improving dialogue summarization in virtual reality environments or enhancing the accuracy of automated meeting minutes. In the research titled Highway Value Iteration Networks, scientists have introduced an improved version of value iteration networks, a type of neural network designed for planning tasks. The problem with traditional value iteration networks is that they struggle to plan for long-term goals because training very deep networks is difficult. To overcome this challenge, the researchers incorporated a technique called highway value iteration into the structure of these networks. This innovation enables the training of much deeper networks, which can plan for hundreds of steps ahead. The conclusion is that these new highway value iteration networks outperform traditional ones and even advanced neural networks in long-term planning tasks. The impact of this research could be significant in areas such as autonomous driving, robotics, or virtual reality, where agents need to make decisions based on long-term consequences. For instance, An autonomous vehicle can use this technology to plan a safe route hundreds of meters ahead. In the research titled Qigel, a new approach to compressing key-value cache memory is introduced. The key-value cache stores large amounts of data required by language learning models, which can consume substantial memory as sequence length increases. Traditional quantization methods reduce memory usage, but introduce additional overhead due to storing quantization constants. Shaw eliminates this overhead by using a Johnson-Linden-Strauss transform, followed by sign-bit quantization, allowing for a more efficient compression of key-value cache data. The conclusion is that Qigel can reduce cache memory usage by more than five-fold without compromising accuracy and achieving faster runtime when applied to various language learning models and NEL tasks. This research has the potential impact of enabling faster and more efficient processing of large data sets, which could be beneficial in applications such as natural language processing, machine translation, and question answering systems. In the research titled, "What is the best way for chat to translate poetry?" researchers investigate how well large language models like chat can translate poetry from English to Chinese. They found that while chat does a decent job, it still struggles with capturing the nuances and complexities of poetic language. To improve this, they developed a new method called explanation-assisted poetry machine translation, which uses explanations of the original poem as guidance for the translation process. This approach outperforms traditional methods in both human and machine evaluations. The conclusion is that this new method has the potential to significantly enhance poetry translation tasks. The impact could be substantial, allowing for more accurate and culturally sensitive translations of literary works across languages. Potential use cases include enabling cross-cultural exchange and understanding through literature, or even assisting writers with multilingual projects. In the research titled Files, a novel approach is presented for learning semantic video representations in a fully self-supervised manner. The idea is to leverage text related to video content during pre-training to achieve more meaningful video representations. The proposed method, Files, uses a patchwise video text contrastive strategy and a masked encoder-decoder structure to predict masked feature semantics in language space. This approach demonstrates remarkable transferability on downstream action recognition tasks, achieving state-of-the-art results on challenging datasets. In simpler terms, this research is about teaching AI models to better understand videos by relating them to text descriptions, which can have a significant impact on applications like video search, recommendation systems, and virtual reality. For instance, with Files, an AI model can more accurately identify actions in a video, such as cooking or dancing, and provide relevant information or suggestions. In the research titled, "Are Language Models Rational?" the case of coherence, norms, and belief revisions, scientists investigate whether machine learning models, specifically language models, can be considered rational. They focus on a subset of rational norms called coherence norms, which refer to how well a model's beliefs or predictions align with each other. The researchers propose a new way to measure the strength of a language model's beliefs based on its internal probability calculations, and find that some language models do follow rational coherence norms, while others don't. This research is significant because it has implications for AI safety and alignment, as well as understanding how language models behave in general. For instance, if a language model is not rational, it may produce inconsistent or misleading responses which could have serious consequences in applications like virtual reality or chatbots. In the research titled Text to Events, synthetic event camera streams from conditional text input, scientists have developed a method to generate synthetic event camera streams using text prompts. This is important because currently there is a lack of large labeled event camera datasets for training deep network algorithms. The proposed model uses an autoencoder and a diffusion model architecture to produce smooth synthetic event streams of moving objects. According to the research, this method can generate realistic event sequences of human gestures with classification accuracy ranging from 42 to 92. This breakthrough could have a significant impact on various applications such as robotics, autonomous vehicles, and virtual reality, where event cameras are used. For instance, this technology could enable robots to better understand their environment by generating synthetic data for training. The potential use cases are vast and exciting. In this research, the authors tackle a common problem in offline policy learning, which is when an artificial intelligence system learns from existing data rather than through trial and error. The issue arises because the data was collected using a different strategy, causing bias and high variance in the learning process. To overcome this, researchers use a technique called Pessimism, which adds penalties to the importance weights of the data points. However, there hasn't been a unified framework to analyze these penalties until now. The authors introduce a comprehensive PAC-Bayesian framework that enables comparison of different penalty techniques and derives a tractable generalization bound. Surprisingly, their empirical results show that standard importance weight regularization methods are effective, contradicting common understanding. This research has the potential to improve offline policy learning in various applications such as robotics, healthcare, or finance, where collecting new data through trial and error is not feasible or safe. In the research titled SelfReDepth, Self-Supervised Real-Time Depth Restoration for Consumer-Grade Sensors, scientists have developed a new technique to improve the quality of depth maps captured by consumer-grade sensors such as those used in virtual reality headsets or smartphones. These sensors often produce inaccurate or incomplete data, which can be a major problem for applications that rely on accurate depth information. The researchers' approach, called SelfReDepth, uses self-supervised learning to denoise and fill in gaps in the depth maps in real time without requiring large amounts of training data. According to the abstract, this technique outperforms existing methods and can process depth videos at over 30 frames per second on commercial depth cameras. The potential impact of this research could be significant, enabling smoother and more realistic experiences in virtual reality, augmented reality, and other applications that rely on accurate depth sensing. And there you have it, folks, a comprehensive breakdown of the latest advancements in artificial intelligence research. I'm your host, Adam Infinity, and I'm thrilled to bring you this content on Singularity today. Before we wrap up, I want to remind you that every single aspect of this video was generated by AI, from writing the script to creating the narration. Yes, humans can finally take a break and enjoy their free time while AI does all the hard work. On a more serious note, these breakthroughs have the potential to transform industries such as customer service, virtual reality, autonomous driving, and many more. I encourage you to review these research articles on your own and explore the exciting world of AI research. Thanks for watching Singularity today. If you liked this video, please like, subscribe, and comment below with your thoughts on these groundbreaking studies. And don't forget to hit that notification bell to stay updated on the latest advancements in artificial intelligence.